Okay, with the ovary, the ovary has a few ligaments that are going to be related to it, and some structural components and cells. There's the ovarian ligament, so this would be the left side ovary, and it would be held in place by the broad ligament. The ovarian ligament holds it in position in that location, and then you'd also have the round ligament that's holding it anteriorly to the abdominal wall. Within the ovary, or on the surface of the ovary, we have simple cuboidal cells, specialized for secretion and release of the oocyte at 10 days in. What we have here is the different stages of both the follicle and the oocyte development. So each of these primordial follicles are in prophase 1, or have already crossed over when the female has been born. And so she's born with all the eggs that she'll ever have. Attrition affects the number of those, and at puberty she would begin release of those, and one of these would go through the stages of meiosis that month and be released and be stopped in metaphase 2, and we'll talk about that in a moment. So this is a primordial follicle. It's in prophase 1, and crossing over has already occurred. Or this is a primordial cell. This follicle that is developing in this one here is developing cells around it, so this would be a primary follicle and a oocyte within it. You have a space begin to develop. That space is the antrum, and you get a double layer of cells outside of the oocyte, and that indicates that you've gone from a primary oocyte to a secondary oocyte, and now it's completed the stages of meiosis 1 and gone into metaphase 2 of meiosis 2, and is now ready to be released, and that is going to coincide with the follicular development that's occurring, and the cells that are being made in the follicle are actually going to be producing estrogen at the time, or throughout this time, and it'll rise until the point of the spike in FSH and LH, which will then trigger the Graafian follicle to become vesicular and release the oocyte, being picked up by the fimbria, taken through, and if fertilization occurs in the fallopian tube, implantation will occur. The corpus luteum here will develop and nourish that developing zygote until the point when the placenta can take over for it. If menstruation occurs or sloughing of the endometrial lining because no implantation has occurred, then this corpus luteum will become degenerative tissue, and the corpus albicans, scar tissue, will result. So again, we have here the scar tissue. We have the Graafian follicle, and in between, or that has come out of it. Here's a different one here. We've got in addition to that, we have with the initial split of the cell, we have the oocyte that splits it at the end of meiosis 1, or chromosome number is reduced, and you have this atritic polar body that's essentially going to nourish the one that outcompetes it, and the oocyte is here, but this cell is being consumed. So that's the polar body or atritic cell, and this is the primary oocyte and follicle. This is the secondary follicle, and the oocyte here is in metaphase 2, as it is here, and it's going to be released as it becomes Graafian, and that's about 10 days into the ovarian cycle. Following this, you would have that spike in LH, corpus luteum is produced from 10 to 14 days, and if implantation doesn't occur, then you have the secretory phase and degenerative phase, essentially, and the loss of the endometrial lining, and you start all over again after 28 days. So we'll go through each part of that, but in this model you have primordial, you have primary and atritic, you have secondary, you have vesicular and Graafian follicle, and the release of a secondary oocyte halted in metaphase 2.